Okay, so let's go ahead and work on the warm-up. This is from yesterday's lesson where you're doing half a circle or semicircle and a quarter circle. So it says, find the area of the semicircle below, round the answer to the nearest hundredth place. So if you look at it, what are they giving you? What information did they give you? What's this information here? Diameter. Okay, so that equals diameter. So I'm going to go ahead and find the area. But to find area, we need what measurement? Radius. So in order to find radius, you do diameter divided by 2. That gives us radius. So here the diameter is, what is it?
Is that a 10?
It's 18. So 18 divided by 2 equals R, which is 9 equals R. So now that we know that radius is 9, then we could go ahead and do our area formula. So A is equal to pi radius squared. So A equals to pi 9 squared. And 9 squared is what?
81.
81 pi. Okay, so now because it is only half of the circle, then I could go ahead and divide this by 2. So A will equal to 40.5 and pi. Now this would be your answer in terms of pi. But we don't want it in terms of pi, so we need to continue multiplying. So 40.5 times 3.14. So let's go ahead and multiply that. I'm going to need more space here. Oops. So 4 times 5. 4 times 0 plus 2, 4 times 4, 1 times 5, 1 times 0, and 1 times 4. And then remember, when you're doing a third number, you have to add 2 zeros, and a lot of you make that careless mistakes. So 3 times 5, 3 times 0 plus 1, 3 times 4. Okay, now we go ahead and add that. So that's 0, 7, 11, 7, 2, and 1. So how many decimal places do I need? 2? 1, 2, 3. It's 3 decimal places. So my answer is going to be 127 and 17 hundredths. And remember your centimeter squared. Okay, so let's go ahead and start on the next one. And the next one has find the area of the quarter circle below, round to the nearest hundredth place. So if you look at it, it's giving you the radius. So the radius is what we need to find area of the whole circle. So let's go ahead and do area is equal to pi radius squared, and that's going to be divided by 4. So what we're going to do, we're only going to use 3 for pi just to make it a little bit easier. So let's go ahead and do pi. Radius is 13 squared. So we're going to do 13 times 13. That's 9, 3, and 1. So that's 169 pi. So now we're going to go ahead and divide that by 4. So A equals to 42.25 pi. And we're going to leave it as in terms in pi. So you have a handout where it has what is a composite figure. Okay, if you notice, these are not shapes where you have your formulas. They're different shapes. So if you think about it, can't we take out shapes that we already know from these?
Yes.
Okay, so then what do you think a composite figure is?
Different but similar, like shape.
Yeah, it could be more than one figure in one. So it's a combination of figures to make one. So let's go ahead and write that. And if you notice, we do have a 4 in your handout. So what I'm going to have you do, I'm going to have you look at it with a partner. So you do have somebody that's close to you. I don't need you to move. I need you to work with the person that's next to you or around you. So what I want you to do is make sure you're looking at the composite figures, and all you're doing is actually cutting it into more than one figure. So in other words, you're going to cut the figure into 2 or 3 different parts. So I'm going to give you about 10 minutes to do that. So go ahead and get started. And the reason we're doing it like this is because I want to make sure that you see the figures that I see. So let's go ahead and get that started. Okay, so now that you had a chance to discover, we're going to go ahead and go over the 2 shapes you cut the composite figure into. So if you look at number 1, where would you draw a line to make the 2 shapes? Or what 2 shapes did you find?
Like under the 6 centimeters. Yeah. Triangle and a rectangle.
A triangle and a rectangle? Okay, so then that means you're drawing the line here, right? So there's a triangle and a rectangle. Okay, so what you needed to do is you needed to put triangle here. And the formula for triangle is equal to A equals half the base and the height. And then a rectangle here. And that would be area is equal to base and height. Okay, did anybody see 2 different shapes? Come on, I saw your paper, so yes, you had 2 different shapes. What did you have? If you draw the line here, then you have a trapezoid, which is area equals half of base 1 plus base 2 times the height. And then you had the rectangle. So either one will work to do that, to actually have the area of the whole thing. So what would you need to do is find the area of the rectangle, find the area of the triangle or trapezoid, and then add up the area. So you would actually add the 2 areas. So let's go ahead and find the area of the 2 shapes now that we understand what are the different shapes. So I'm going to go ahead and start with a blank page. So what we're going to do is we're still going to do the rectangle and the triangle. So again, rectangle, all you need is the area is equal to base times height. So we have the base of 10, the height of 4, or vice versa. So we're going to go ahead and multiply that, and that's going to be 40. Okay, so now let's go ahead and find the area of the triangle. Now the triangle, remember, when you look at it, you cut the base, that base that was 18, you cut it, and you took some away. So that means you're going to have to make sure that you get the exact measurement. So if the whole thing was 18, and this was 4 because of the top part, then that means we're going to subtract that. So we're still doing, it is a triangle, and the area is half of base times height. So you're going to take half of 14, because this is 14 here, times, in this case, again, we have this whole thing is 10, but since this part is 6, then this has to be 4 times 4. So if you do half of 14, that's 7 times 4, so the area of the triangle is 28. So this is going to be 28. So now you have the area of the rectangle and the area of the triangle. So then that means we have to add the 2 in order to get the area of the whole shape. So this is going to be 40 plus 28, and that gives you 68 square centimeters. And that's the whole area. Okay, now, so number 2, we have 2 shapes in this composite figure. So what we're going to do, we're going to go ahead and draw a line here. So that means we have a rectangle and a semicircle. So the formula for rectangle is area is equal base and height, and the area for the semicircle, area equals pi radius squared divided by 2. So first we got to see what they're giving us. So in this case, 10 did not show on your paper, but it was supposed to be 10 millimeters, so that's a given measurement. So in order to find area of a rectangle, all you have to do is 10 times 8, which is 80, and I go ahead and write it inside that rectangle. So I'm going to go ahead and now find the area of the semicircle. So remember, to find area of the semicircle, you have to find the area of the whole circle and then divide it by 2. So let's go ahead and do that. Now the measurement they give you is what? And in this case, since that's the line we wrote, that's the same as this line. So that means the measurement given was 8 meters. So if you look at this, this is going to be diameter. So we need radius. So remember, to find radius, you need diameter divided by 2 to give you radius. So that's 8 divided by 2. So that's going to be 4. So in order to find that, we're going to go ahead and use 4 as radius. So we're going to go ahead and do that. So we're going to pi 4 squared divided by 2. When you're doing this, make sure you do the square part first before you divide it by 2. So that's going to be 16 squared, 16 pi squared. 16 times pi is your area, divided by 2, so now you're going to have 8 pi. So now I'm going to multiply 8 times 3.14, so that's going to be 32. 8 times 1 is 8, plus 3 is 11. 8 times 3 is 24, plus 1, 25. So my area of the semicircle is 25 meters squared. So what we're going to do, we're going to go ahead and add the 2. So I'm going to add the 80. And remember, when you have a whole number, the decimals at the end. So my answer is going to be 105 and 12 hundredths meters squared. So that's what we write over here. And that is my answer for my composite figure. Okay, on this next one, again, if you notice, we still have the 2 shapes. We're going to go ahead and put a line somewhere. So I could put the line on this side here. Okay, so that means that you have a rectangle and a square. Now, guys, what does those lines mean? What are those lines?
Half marks.
They're hash marks, but what do they mean?
It's where the half of it is. Dang it. I was close,
Okay.
Right? Oh, I remember doing it. I know what they mean, but that's only a shot.
Okay, so if they tell you that this is 5, then that means this is also 5, this is 5, this is 5. So that means that those are 5. So if all of those sides are 5, what would this measurement be? 10. So remember, you do need to do a little bit of math before you actually try to solve it. So the area for a rectangle is A equals base times height. The area for, or the formula for a square area equals S squared, or A equals base times height. Okay, so remember, you have to do a little bit of math when you're cutting your shapes. So one of you said that just to do the line in the middle.
Wait, what?
Well, that creates what?
What square?
2 trapezoids, right?
Yeah.
And then can we do 2 trapezoids?
Yeah.
As long as we have the measurements of everything we need? Yes, you can.
Oh, I knew it.
Yes, you can. Okay, remember, you do need to add the area for both. So now that we have the two parts of this, I'm going to go ahead and move it over so we could actually find the area of the 2 figures. So in this case, we have a rectangle and a square. Now to find the rectangle, all I have to do is have this measurement, which is A equals base and height. So that's going to be 5 times, I need to find out this measurement. Now, if you remember what I told you, that those tick marks are measurements, that means that they're congruent. So if this is 5, isn't that part up here that's 5? And if this is 5, then that's 5. So when you add them up, that's going to give you 10. So that means my height or base is going to be 10. So when we do that, that's going to be 50. So we're going to go ahead and write that as 50 inside. The square, you do the same thing. You're still finding area. You use base and height. So the base is 5. The height is 5. So that's going to give you 5 times 5. And 5 times 5 is 25. So this is going to be 25. So 50 plus 25 will give you 75. And that's going to be square feet. And that is the area of my rectangle or composite figure. So now what we're going to do, we're going to go ahead and move our figure over. Move everything over, and we're going to work on number 4. Now number 4, we have a composite figure, and you have 2 shapes. The 2 shapes is a rectangle and a trapezoid. So the rectangle, we have the measurements. So A equals base times height. Base times height is 8 times 3, so that's your base and height. And that's going to give you 24. So I know this rectangle is 24 square inches. Now for the trapezoid, we are using the formula half. So A equals half of base 1 plus base 2 times the height. And what we're going to do, we're going to go ahead and find out those 2 measurements. So if you look, you have base 1, or it could be base 2, it doesn't really matter. We have 30. So we still need the half there. So 30 plus base 2 is going to be 8. Since this is 8, that's going to be 8. And then the height is this dotted line, which is 10. So now we're going to go ahead and add the bases. So half equals 38 times 10. So half of 38 is 19 times 10. So the area for the trapezoid is 190 units. So then all you have to do in order to find out the total area of this composite figure is add 24 plus 190. So that's 4. That's 11. So then the area is going to be 214 square inches. So basically, in order to find the area of any composite figure, figure out what two shapes are within the figure and then find the area of both, or maybe it could be 3 or more, and you find the area of all the shapes and then add them up, and that gives you the total area of the composite figure.